If anybody wants to take notes, feel free. I take notes like with the pen, old school. So no need, but all right. So just going through the agenda. Actually, we'll look through the last meeting and see if there's any actions that aren't on the agenda there really quick. Let me do that. Okay, so I think everything here is covered. Starting with issue 185, which is strategic initiatives, champions, like we have on TSC. So I think, Matthias, you opened this one? Yes.
Yes. The idea is basically to have a way to people from outside the working group to be able to know what we are working on and to know who is trying to move each task forward. It's very similar to what we have on the TSC. I think maybe if someone from the TSC could comment about how it works there, it would be great. Maybe Ali.
Sure. So at the TSC level, like in the Node project overall, there's way too much stuff happening. So the idea behind TSC, and that's my interpretation of it, I can't speak on behalf of the whole TSC, is the idea is that these are some bigger items that need to be tracked at the project level broadly, where we do an update to the TSC from periodically. So that's how it works. It's not really something that's used for every topic of discussion. So the difference I see in this working group and in what the TSC is trying to do is you here, I think in our working group, every thing we're working on, every issue, I would argue in our working group is an important thing that we're working on. I guess our objective is whatever needs to be done from a diagnostic perspective. So what I'm trying to figure out is what would be the difference between an issue on a repo versus a strategic initiative. I think it's less clear to me for this working group. So there are some things that require concerted effort over a longer time. Maybe that's a difference, but I don't know if calling it a strategic initiative would make a lot of sense other than just an issue that we care about. If something is not important, I think in this working group, it would just not be prominent or would not get worked on.
Yeah, I mean, I wonder if maybe we're just getting sort of hung up on the, maybe the terminology between strategic initiative and issue. I do think maybe in some of these things, I know that when we had the meeting in February, like there was a handful of names assigned to some of these things. I don't recall if like where that's actually written down somewhere, or if necessarily any of these issues have specific owners assigned to them. I think the meta point that I read out of it is like, do we have some way of saying like, hey, Ali, you're on hook for XYZ or something like that, to the extent that somebody can be on the hook for something in a volunteer organization.
Yeah, I agree with you. I think it's the terminology. I mean, maybe we're getting stuck on terminology between champion and strategic initiative. In the past, we've struggled to find volunteers to sort of take on action items, and that was a challenge. And I think maybe this is a way to make it more proactive.
So I'm happy to go sort of, either way. Like, one is we can say like, hey, these are the set of things that we claim are important. you know, and we can have a table like this with a name and a link to the issue. And if something isn't getting traction or it's falling off, or, you know, it's by the way everybody's dealing with it, it's just, you know, it's not important, we can eventually move it off. I don't think by having something in this list, there's necessarily a claim that it is important. I think maybe it's something that, you know, there's an agreement that maybe it should be, not necessarily that it is. But I'm happy to, you know, whatever people think is useful. I don't have too strong of an opinion. I mean, I think the simplest thing is just go through these different issues and just assign them to individuals, and then there's less tracking and less stuff to get out of date. Matthias, I don't know if you had any thoughts or comments on it.
Yeah, about having these issues, the problem I see about that is we have 42 issues on the diagnostic group today. And for example, the CPU profiling stuff have at least 3 or 4 issues related
Everyone.
to it. Hello.
Sorry, I was late.
Oh, hey.
Async Hooks also have 2 or 3, I think. Same for trace events. So it's hard to know.
Just saying, there's just some
overall view.
Yeah, there's broader, higher level things that sort of incorporate some subtasks or sub-issues, and we can organize things hierarchically.
So, but if the feedback is that we are not good at keeping issues up to date and sort of having clear owners for those issues who are basically doing the bookkeeping, moving issues along, then adding more processes isn't going to help that, right? So now there's more lists that we have to keep up to date that we probably wouldn't. So I think the feedback is very valid, that there's lots of issues that we are probably not doing a good job keeping up to date and consolidating into sort of maybe tracking issues. I think maybe that's a feedback we should take and go improve on that. I do wholeheartedly agree that I think having owners assigned to different things would be a good idea. So as long as, I think the thing that's going to make it work is that people are actually going to do something. So having an owner doesn't help if no work actually gets done.
I agree with that. So yeah, so do we just want to say like, hey, we should go ahead and we should have tracking issues for these things if they don't already exist, and we should make sure that sub-issues are appropriately linked underneath them. And once that's done, we can, you know, where appropriate, assign names as owners of the top level issues. Is that a fair path forward?
Yeah, and I'll take the action item of going and cleaning up the issues for async hooks, since I'm already on the hook for that.
Okay. So then we need to make sure that issues are cleaned up and that there's tracking issues for the broader level things, and then we can have where there's not a parent or a clear owner, we can have a discussion about that at, say, the next meeting. Does that sound fair?
Yes.
Okay, great. And then is there some name or something we want to use for like these top level issues? Just put like some like, you know, square bracket tracking, square bracket, you know, so we can look at, scan the list and say like, oh, here's a tracking thing for trace events or something along those lines. Or is that too much?
I think maybe having a label for them to help filter.
Okay.
But I don't have ideas for names.
Okay. Label's good. We can have a label. I'll create such a thing. Okay, I guess the other thing there is like if folks can, you know, go in and, you know, maybe take some without assigning stuff, take, you know, like a lead volunteer for the async hook stuff. You know, I think, you know, you can take the async context stuff and try and sort of organize those things into sort of, you know, the appropriate hierarchy with the sort of top level tracking issue and then links to the other things that are related underneath it. Sound fair? Anything else on 185, or are we clear to move on?
I'm good to move on.
All right. So diagnostic channel number 180. I don't think we have any update here. I don't know if anybody's on the call that's been looking into that. I think maybe Stephen, you're on now.
Yeah, I made my prototype thing. I don't know if anyone's looked at it since I mentioned it at a previous meeting.
I have not. So it sounds like no update here then. Is that fair? Okay. Visualizing async context. We should maybe just, I think we should maybe move this off the agenda unless, Kelvin, you had specific stuff that you wanted to drive here. I think you'd open this. I wanted to talk about it a few weeks back.
I don't have
179.
anything right now. I haven't had a lot of time to work on this specific topic, so.
Okay, I'm just going to remove it off the agenda, and if you wanted to come back on, then you can put it back on. There may be some overlap with some of the stuff at the demo at the end.
Okay.
So, okay, number 168. Again, if people have, suggestions or ideas about something that they want to go and deep dive on, I think to comment in here, and then we'll periodically try and schedule some of these. I think we've got some, we've got one. I think we probably need to schedule it with this async context stuff that we've been talking about. Anybody have any comments there on 168? Okay, moving on, 148. This is Node CPU profiling roadmap. Matthias, you want to talk about that one?
Yeah, since last meeting, we opened a pull request to the Node, to the V8 repository to introduce the code event listener API we have been discussing. And it should land in probably next couple of weeks.
Great.
Yeah, I'm currently reviewing that. I'm kind of busy the last couple of days, but I think we can get it landed soonish.
Great. Anything else there?
Don't think so.
Great. Okay. Async hooks, the stable API tracking issue number 124. I think there were some actions from the last one that Ali, you volunteered for about trying to define some exit criteria, or what we think are exit criteria for this. I don't know if you made any progress on that, or if there's been any other progress on this.
So, the progress, some progress. I don't have an exit criteria list written down, but I think the first step was trying to figure out how does promise hooks play into this.
Okay.
So I think there is an update on that front. I think there's a document that Young put together that talks about some of the options we have to deal with the issues with promise hooks. Is this a good time to go over that doc?
Yeah, I think it's listed somewhere on here, but we can certainly talk about it now. So why don't we just segue into that?
Yeah, so let me find a link to it. Young, do you want to walk us through the document?
Yeah, sure. So it's mainly an effort to try to address the performance issues, which is the biggest blocker right now, I think. So there are a couple of
Can I ask a quick question? So I know we've discussed performance issues being a blocker, and I thought there was some discussion last time about having some measurements. Do we actually have a quantification of what this performance impact is?
Yes, so Benedict actually put something together. He measured on a particular happy benchmark that the performance drops by 70%.
7.0 or 1.7?
7.0.
Okay. So I think that's very clearly a performance problem. Okay, good to know.
And that's a promise-heavy workload.
So the thing is, the gap actually gets wider as we improve V8. So it used to be that in Node 9.4 it's only a 30% performance hit. But with the newest V8, with the performance improvements that Benedict has been adding, he has added a couple of fast paths that don't apply to promise hooks, and the gap got to 70%.
Okay, are those fast paths related to that bug I saw where the promise hook semantics changed?
No.
That's a different, totally different.
Yeah, the bug is just one thing that happened, but it's not a cause for the better performance.
Okay.
Yeah. So for background on the fast path for that Jan is talking about, so the V8 team has been working on improving promise performance in general, and the challenge is that when promise hooks are enabled, then those fast paths do not apply anymore. So it has to take the slow path, which means that promises over time will become faster and faster, except when you have async hooks enabled, in which case the performance is not going to be great.
All right. So if you have an application that's really heavily based on async await or promises in general, this performance difference becomes very significant.
Yeah. So I mean, so I read the doc. I added a few comments, questions mostly.
But I guess my question kind of segued us off. You were going to give us an overview, so.
Yeah, please go ahead.
Okay. Yeah. So all right. So essentially, there are a couple of big problems. So the first thing is that for every await, we create, I think the number was 4 promises. At least one of them is what the spec calls throwaway promise capability, which probably doesn't matter to most users to actually observe them. And for every one of those 4 promises, we have to call all the hooks in the set of like during its lifetime, including init, before, after, resolve, and destroy. And all of them go through C++, so the VA doesn't even have a chance to know whether the user actually defined something. It always has to call into C++. Then on the Node side, from C++, it checks whether there's anything installed, and then calls that hook if there's anything installed. So 4 times 5, that's like 20 C++ calls potentially for every await, which is expensive. And what comes in addition to that is for every promise, we also create on Node side a weak global handle to be able to do this destroy hook, to be able to get a finalizer call. And that also adds quite an overhead to the garbage collector, because weak global handles, like V8's garbage collector is written in a way to, mark what's alive and not mark what's dead. And having this requirement of calling a finalizer is kind of expensive for the garbage collector. So those are the problems. And the proposals that we have try to address those. So I guess I will start with the simplest one. The simplest one would be for promises that are either not observable or at least formulated in the spec that suggest that it's not really interesting for the user, like the throwaway capability that I mentioned. It might be not necessary to actually fire any promise hook.
Yeah, I guess my question there is, and maybe I could read the spec, but I'll ask it. Like, if they're not observable, why do they exist? And is it really the case that they're always not observable, or are there edge cases where they are observable?
I'm not entirely sure whether they are not observable, but I think the way Benedict phrased it was that it's just easier to write the spec this way.
So another way of looking at this might be that I think we should, the behavior we want for promise hooks, we should be conservative as a starting point. So exposing the promises that we think are unobservable as a starting point is giving user more information. And if that's the semantics we want, if we tie ourselves to those semantics, we always have to support those semantics going forward. Right? So the question is, what is the use case for people to observe these unobservable promises through promise hooks? And I don't have a use case.
Well, yeah, I mean, I guess the question is it possible for somebody to end up with incorrect or lost context because these non-observable promises are actually observed in some edge cases and the hooks aren't there, right? So in that case, what you have is you've got a break in correctness, right, for what we're ultimately trying to achieve, which is we understand async context, right?
Yeah, so if they're truly unobservable, then I don't think we can break context, right? So the question is, are they really unobservable?
Yeah.
Yeah, I don't have any data on this, unfortunately. But let's move over to the next one. So the second proposal that we had was instead of defining promise hooks as C++ callbacks through the V8 API, they should instead be defined as JavaScript callbacks. That way, V8 doesn't actually have to call into C++, and then from C++, Node would call back into whatever JavaScript there is. Instead, V8 would just know whether there's anything installed, and if there's anything installed, call it, and if there's nothing installed, don't call it. And that also opens up the opportunity to implement inlining so that we can directly inline those JavaScript callbacks into whatever is firing that promise event. What that also changes is that the promise hooks will not be installed on the isolate anymore, but on the native context, which means that promises created from a different native context will not cause like the promise hook that we installed to fire, which is kind of important if you consider the use case of Electron.
So I expect this
So you are
controversial.
What'd you say, Ali?
I contended that this change is uncontroversial, and I would be really interested in hearing opinions on this.
You mean this switch from native to JavaScript?
Well, that one is just, I think that one is really, really uncontroversial in my opinion. But the other change, I think it would be better if the way the hooks were specified were JavaScript rather than C++. I think that's the JavaScript is the primary use case for async hooks. So I think that's the one we should optimize for rather than C++.
Yeah, I wholeheartedly agree with that. And I think, as Yang was saying, like it has a huge impact on number of boundary crossings and being able to make it all visible to the optimizer.
Yep. Because so far, the JavaScript functions that will be called and installed by the user are held by Node.js, and V8 has no way to know whether there's anything to be called. And so should we move over to the last item?
Sure.
Yeah, so the last item is, I guess, the most controversial one. We propose to remove the destroy hook. and so please hear me out. We figured that there might be only 2 use cases, or we should probably separate 2 use cases. One use case is that you use the destroy hook to clean up metadata that you use while tracking, while keeping tracking information for the async context. So essentially, what usually happens is that you get the init hook, and that gives you the ID and the resource. And in userland, you create the mapping between ID and the resource and whatever tracking metadata you want to keep. And you only keep this metadata around until you until you get the destroy hook for the same async ID. So for that, we thought that, well, if that's the only thing that you need the destroy hook for, why don't we offer a way to, not only expose the async ID to every hook, but also the resource itself, so that the user doesn't have to, keep the mapping between the ID and the resource anymore, and instead store the metadata directly onto the resource, or use a weak map to map the resource to whatever metadata you want to keep. This way, you don't even have to wait for a destroy hook anymore. The weak map, or like if you store the metadata on the resource itself, would just get garbage collected naturally.
So can I ask?
Yes, please.
Can I ask a quick question? So I mean, maybe, because I can imagine some things like, suppose I was writing a diagnostics tool and I wanted to look for unhandled rejection and help you figure out exactly where you were out, creating the promises that led to this, right? In that case, I feel like you do need the destroy hook, because that's really what you want to know about. So
yes, I'm coming to that. I
guess I wonder if there's a case where it's like, rather than eliminate, can you split this into 2 concepts, which are like the async context and the lifetime are sort of 2 orthogonal parts of what you might. Okay, so go ahead. Sorry.
Yes, I'm coming to that. So the use case I just talked about are usually ones where you want to be enabling this during production, and in those cases, having performance regressions would be very bad, right? You want to be able to like, if you're an APM vendor, you want to be able to turn on async hooks all the time, but not get the performance hit that you would get from offering the powerfulness of destroy hooks. For the case that you all just described, where you actually want to be able to call a finalizer, that's not only to sort of emulate weakness. We could also just specifically for those cases use weak references. So weak references is one thing that's going to be going through the stages at TC39, and until it's implemented and like spec and implemented, we could use a polyfill based on what we already use with weak global handles to implement this functionality. But what I'm suggesting is not bundle this with the promise hook, because if you bundle this, nobody has the choice of not having destroy hooks anymore.
Right. So you kind of want to have like, I have promise async hooks and promise lifetime hooks is 2 separate things you can turn off and on independently.
Yeah, well, the lifetime hook would not even be limited to promises anymore.
Okay, yeah. I'm just saying it was promises, but yeah, that would be awesome.
Yeah. This way, if you really want finalizers, you pay the cost. But if you don't actually want them and only want to make sure that your metadata is weakly kept alive, then you don't really have to pay the cost.
Somebody was going to say something.
Me, but it's this is very.
This is very breaking. Yes, I know.
This is very breaking. I am not. I'm not super into that, or at least it's something that we need to think through very well.
Okay. So of those three proposals, I think the one that bites us most is the one of not having destroy hooks, because the thing about not having destroy hook also means that you don't actually have to go into C++ to allocate the weak global handle anymore. But so the other options that we considered were either to just do nothing and just assume, okay, 70% regression is fine because it's only there because we made promises faster. Might be okay. Or we could just do a subset of the three proposals that I listed. There will probably be performance improvements for every one of them. It's not entirely clear how much. But like I said, a subset would work because most of them, like all three of them, can be implemented individually and are somewhat orthogonal to each other. The third thing that we already discussed a while ago is to make the promise constructor monkey patchable, but that doesn't really help with the destroy hook issue. So the idea here is that basically you make it monkey patchable so that the await call would call the custom promise constructor, and you would then monkey patch everything in there to hook into everything. That would mean that everything stays in JavaScript, but then, like I said, the destroy hook thing is not addressed with this. The last thing is to revive the zones proposal, but that will be slow, and it also doesn't address the destroy hook issue.
So how does the zones proposal sort of fix this? Let me ask that.
Well, zones proposal would be integrated into the language, right? And
which means there's no longer the need for all of these lifecycle events around promises and more generally, async resources such that somebody can track async context. Right?
I guess the zones proposal would be somewhat covering the proposal for removing the destroy hook and the proposal for moving C++ callbacks into JavaScript callbacks, because once you implemented zones as a native feature in the language, you would have to use JavaScript callbacks for those, or like somewhat similar. And I think,
but does the zones proposal even have the notion of like callbacks around lifecycle?
I don't think so. No.
Yeah, I don't think it does.
So, but proposed here, right? So what we are proposing is that weak references are a better way to get the finalizer callback rather than a destroy hook directly. That's one of the proposals here as well. So I think the same would apply in zones. So if you want a finalizer for a promise resource, you could do it using a weak reference.
Right, but I guess that, so here's the thing that sort of occurs to me, right, is that there's an API which maps lifecycle events around things, right? And that's being used to sort of track async context, right? And I kind of feel like that's maybe the wrong thing, right? And I kind of feel like when I see like, hey, we should, start doing, making a bunch of changes to optimize for these lifecycle hooks, when the real goal, I believe the real goal here is to track async context, right? Then it feels kind of wrong. And it's like, I think the zones thing and my read on that is it gives you this sort of some of these capabilities around async context, and it lets you implement those in a way that doesn't require all these callbacks around the lifecycle events, which lets you it obviates all these perf problems we're talking about, right?
Yeah. So one thing that the zones proposal addresses is that the async context is not represented as an integer ID, and using integer ID to weakly hold onto something is just impossible. And that's why we're proposing to also just expose the resource on every hook, like beyond the init hook. This way you can just use the resource as a weak key, because using the async ID as a weak key is just not possible, which is why you need the destroy hook.
So, and then if this is
so one thing that is missing from this discussion is why we do have an async ID in the first on the first thing.
I'm not sure.
That's something that it will be good to ask to Trevor, and ask Trevor to come by and try to get us that information. To me, it seems it has been every time it has been very weird. Every time I've worked with this, to some extent it makes sense, because then you can correlate and log things and debug things, and it makes a lot of sense. But all of these can be actually added on top to some extent.
Right.
But I mean, I think at some level you need like identity, right? And the question then is, what do you want to use for identity, if not an ID, not an integer ID?
Well, there are a lot of things, like, that if you have a unique object that's created the resource and you can guarantee that that's not shared, then that works just as well. All you care about is something that is equality comparable and unique.
So it's not true. Whenever you want, if you want to do some post-processing on this data, you need a unique identifier that's processable by a machine.
But you can just store something onto the resource, right?
Yeah, exactly. That's what I'm saying. Exactly. No, I agree with that. So that's what this is where I was going. Like you will need to implement it yourself on top of it, but you don't keep track on of the stuff.
Right, and if you just store whatever metadata you want to keep onto the resource itself, then you don't need this like mapping.
One of the things, yes, no, that can definitely work.
So how does this change the Promise Hooks API with respect to what the API is for just the regular async hook stuff?
Well,
can you use the same technique with async hooks?
I would expect so, right? So I think we need a resource on the before and after hook as well. So right now we only get the ID.
And on the Promise resolve hook.
But those are native objects, right? In async hooks at that level.
Well, they are native objects, as in actually wrapper objects that have a pointer to a native object.
I think my only concern would be guaranteeing that you get a fresh one. Because now you need to not just generate a fresh integer ID, but you need to make sure that the underlying resource pointers are different. You can't pool two async chains on the same underlying resource if you're assuming that sort of model. And I'm not, because the spec for async hooks is sort of the implementation defined. It's not clear to me that that's always the case. So that would be a minor concern I have.
Yeah, there's that, and then I think there's also the case of like, what is the identity post-mortem, right? And how do you ensure the identity post-mortem? Well, right. Now with async hooks, you have a unique ID, and you're able to say like, okay, I've got a bunch of unique IDs, and after the process is done, you could construct something interesting from those.
The IDs will still be there.
What's that?
The IDs will still be provided.
So you still have unique IDs, they just hang off of the object.
No, why don't we just provide both the ID and the resource to every hook? Because currently it's only on the init hook, But if you also just provide it on the after and before and the promise resolve hook, that would just make it more useful.
It isn't even a breaking change now, right? It's an extra parameter at the end on the before and after hook and the promise.
One of the main reason it's done in this way was that it's the tracking of the looking up the resources and so on, I think could be done in JavaScript land instead of C land or something like that, probably. But yeah, anyway, yes, it can be done as a assembler minor, really. We will need to do what every implementer of Async Hooks does, which is maintain this map and get the data out of it. It's very tricky, simple to implement it right now.
Mm-hmm.
And I think the argument from Young is that it would be even easier to do this going forward because you wouldn't even need the destroy hook anymore, because all you need to do is keep a weak map. Now you have the resource available, so use the resource as the key in a weak map, and you're done. And that would be more efficient.
It's not even. I don't think it's not even needed. If you can attach data to the resource,
right? It's the same thing essentially.
It's basically the whole point of the destroy hook. So in the concept of APMs and doing all the other things, it's that destroy hook. It's needed for various reasons. One is like keeping track, destroying the context. Okay. Literally. So if I just need to destroy the context, if I can attach the context using a private symbol to my resource, then I have no basically need for having a destroy hook at all. Okay.
Right. Yeah, that's doable.
And
some
this is
not like monkey patching, but for those people, they can keep a weak map, and that would work too.
Exactly. Okay. Like if they need, if it's needed, but that's not a problem. So the major issue is if for some analytics reason you want to know when a resource is destroyed, then you might want the destroy hook. However, because in the destroy I can get the destroy hook when a socket is destroyed, which is actually very important versus a promise. So it's not just promises, okay? That thing also provides me information about when a socket is destroyed.
Yeah, right.
So
generally for async hooks, you do need to destroy hook. That I agree, yes. Like if you wrap a socket or something. But for the promise, maybe we can do something else.
Yes, so it will get somehow tricky, but we can have a mode or something where promises don't emit this destroy hook. Okay, if there is the ref, the second parameter, and so on, it will make an implementer do a lot more work and so on. But if this gives us or gives them a huge less overhead, so if we make it in a way that is incremental, so that we shift from being, so we keep the current set of API and then we enable a couple of different destroy methods, destroy hooks things, where one is only for, or another one that doesn't get promises, okay, let's say.
Mm-hmm.
And then basically the destroy cost is not, then we don't have the destroy cost, which is promise hook cost for just maintaining destroy, then this can be done. And if they want to use the other one, they know what they're going to pay for, okay?
So can we look at this at a different angle? So now
I just want to say one thing. Mm-hmm. I would really like to get everybody at the demo that we have been worked on, and we have 10 minutes towards the end. So
yeah, just one last thing that I want to get out. So far, we have been looking only at the promise performance, right? Do we have any data on micro benchmarks that don't stress promise, but like something like a TCP connection and figure out whether async hooks regresses performance there significantly? Because there you have the same issue.
Matteo had some numbers last.
Yeah, I've lost track of those numbers. I'll need to chase them back. I've been on vacation for the last 2 weeks, and I have no idea what the status. I will know something more tomorrow.
Okay, awesome.
I will just get my two colleagues, David and Ruben, have worked on this, and I just came back from vacation today, so I am completely. This should have been done, but I have no idea what those are.
Okay. As long as we are getting this data, then we can make a decision whether this promise issue is actually a real issue, because if everything else is affected as well, as long as you stress it, I don't know whether we actually have to do anything.
Well, I don't know about that necessarily, but it certainly would be interesting to see some additional data that's not just promises or not promise heavy, to sort of inform some of this stuff.
Okay, with that, I guess we should just move on to the demo, because otherwise we're running out of time.
Yeah, is that okay with everyone? I think there's some other stuff in here. There was a bug. There was some trace event stuff, which I don't know that there's any updates on. I'll give one heads up. We've sort of been working on this kind of the formalization stuff for async context. Haven't seen a lot of feedback from anyone on if people are like, yeah, we think that's the right track, that's the right way to think about things, that's the right set of terminology. What I think we're going to try and do in the next 2 weeks, maybe 4 weeks, there's some other things going on, but is like take that stuff, get it cleaned up, and then open a PR in the diagnostics working group, just to sort of force the issue. And if people are like, no, you guys are crazy, that's the wrong way to think about it, then that's people's opportunity to voice their concerns. So I want to give folks a heads up there. Right now that's in a private repo for well, not a private, but it's in my personal GitHub thing. So and feel free to make comments or PRs on that stuff. I think people have the link. Okay, with that, I'm sorry, is it Matthias? Matthias, you want to share a screen and go ahead?
Yeah, sure. It's a very interesting discussion about the hook stuff, since we've been working a lot with it. I have a couple of slides just to introduce. Can people see my screen?
Yeah, I see on the YouTube channel.
Awesome. So I just have a couple of slides just to give you a little bit of context. We've been working on a new tool called BubbleProf, me, Matteo, and a couple other people. It's a tool that tries to profile async time in your Node.js application, and it's a heavy user of async hooks and all the new instrumentation goodies in Node that I know this working group has been a huge part of. It's part of the Clinic toolchain. If you've heard about that, we also do a lot of other instrumentation and profiling of flame graphing and CPU profiling and stuff like that. But it's an upcoming feature, so it's in our development branch right now that I would love to give people in this working group access to get some more immediate feedback before we go with a full public release. Sure, we can talk about that in an issue or something. But basically, it's a tool that collects async time spent using async hooks and also trace events, and that's a ton of data, as you probably know, on a real application. So it applies a couple of heuristics to group this time into a series of bubbles as a visualization, which is why it's called BubbleProf, bubble profiling. And these heuristics can basically be boiled down to whenever your program is doing something where it's moving from your code to Node Core or from your code to a module, or vice versa, that kind of like defines a boundary of your bubble. So that's like the super quick crash course intro. But I'd love to just show a demo of it because that explains it way better than I can do. So I'm going to switch my terminal here. So like I said, you can install it on NPM if you're part of the development group. And again, I would love to add everybody. Then you can take a program like this. It's just a very simple HTTP server that highlighting that just waits a couple of seconds before ending a request. So it's basically just a server that mimics latency. And if we run this through the tool, we call clean bubble prof, and then we set up a hook here that's fired. The program detects when a TCP server is listening using async hooks, and then you can run a benchmark tool against it. I use Mateo's org cannon here, and it's running the server, and then we pass it the example if you want to run. So basically, what this does is it spins up that server and just starts pounding it with a bunch of data. A bunch of requests to produce a bunch of data. Again, this is like instrumenting it using the hooks in the background, and then it's analyzing that data and opening up in this interesting diagram here. So this is what our visualization of the async hook data looks like. So, like I said, it's called bubble prof because it tries to group data in these bubbles. So each of these bubbles represent async time spent, and these lines from the bubbles represent latency to the next bubble. So you can kind of see in this example here that we have a big bubble that's just called HTTP connection. And if we dig down through this, we'll discover that it's just a bunch of node core stuff. This is what these lines represent. So each color here represents something different. The green color here represents network. The gray around it represents that it's node core. So a lot of time here is spent in node core just handling the equation, which makes sense because our example is not doing much. Then there's a long line that's blue because it's user code, down to a timeout, because there's a long latency down to a timeout. This is again what we expect. There's a tiny bubble in here because not much async is happening in that timeout. And we can kind of dig in here and see that it's on line 5, which in our code is a timeout here. So that's actually using, per the discussion earlier, that context stuff to group that data. And then after that timeout, there's a bit more async stuff happening because it's triggering the resend. So it's a very easy way to just take a program, get a ton of async data out of it, and render these nice, simple in a good way visualizations that kind of help you identify bottlenecks. So a bottleneck here would just be like you probably want to reduce these latency lines. I have a couple more examples I'd love to show you to kind of like get the point across, because if you do something like this, where this is a kind of silly program that's just reading a file twice, but it's basically doing 2 async operations in series, but it's first doing one async operation and then there's an immediate async operation as the child of that. So you can imagine that being a web server instead that would be calling 2 services, and each of the services would be chaining each other like a series. The representation of those is actually also quite nice. So actually, coming back to the discussion before, we actually were super interested also in the use case where you would just run this in production all the time and have these bubbles be produced, assuming there's close to no performance lag on the data collection. That would be really powerful, I think, as a performance tool. So this is the series server. So this is starting to look much more like a real application where you have a smaller bubble now because there's actually stuff happening outside Node Core. There's some small bubbles happening here, which if we click in, we'll expand to the file system recalls. And each of these bubbles are depending on each other. And then this boils down to down here, there's a HTTP end request hidden in here. That's tiny because the end is now just closing the TCP socket basically because we're doing some writes before. And then there's a fork out here because Node is doing a bunch of timers, enroll and unrolls, which is kind of forked in that graph. So you can kind of see here that all your async operations is dependent on each other. And again, the way to improve this application is to shrink these lines because all the next bubbles are kind of tiny. So it's really good at getting that point across, this kind of visualization. And the final one is actually based on the promise discussion. So we have this example of, that's very classic, of a small web service that just reads a file 3 times in parallel and then sends the concatenated result back. So again, you can imagine this being a server that does 3 independent operations and sends them back. And the profile that generates something me and Matteo have been discussing a ton because it's super interesting, especially in terms of diagnostics. Give this a little bit of time. So this is collecting a little bit of data. So it's going to take a few seconds to render it. Here we go. This one is super interesting because this kind of really encapsulates what's going on in the program. So you can see here we have our HTTP bubble. It's still pretty big because it's comparably there's not much happening in our program. Then we have 3 immediately forks of this bubble because it's happening in series, where each of these files are being read. And if we expand down these, we'll see that these are the lines where the promises are being generated. And there's a promise wrapper, so it corresponds to some Node Core operations where it's reading the files. And then we get this interesting profile where there's a big promise on the side. That's the async await promises, where those are getting resolved, and then it's ending the request with some data. So this is kind of like how a parallel visualization will look.
I found an interesting thing is the promise on the left side, because they said there's this nice promise on the top left.
The throwaway promise.
Yeah, the throwaway promise. That's the throwaway promise, very likely.
So this is basically the tool is really good at, like, giving you this kind of underlying information. It's also really good at finding bugs where you have these kind of weird things happening on the side where you're like, what's that happening? That's not really serving any purpose in terms of resolving my requests. We actually used this on some Node Core data, and we noticed that we got a ton of next tick bubbles, and we used that information to kind of find out that we could go in and optimize next tick in Node Core, which I did a couple of months ago, and got a nice 20-30% performance boost out of that. So and that was just by looking at data and being like, there's a bunch of big next tick bubbles here. That's interesting. I wouldn't expect that. So that's basically the tool. So I'd love to, if anybody's interested, give people access here so you can play around with it, and give us feedback on how it plays on real data, if you want. We're pretty excited about it. It's basically just async hooks, trace events, and a ton of statistics to do this.
So are you just grouping stuff in those different bubbles based on the call stack? Yeah.
So what we're doing, let me do the non-promise one because it's a little bit easier to reason about. This one is the classic one. So basically what I tried to say in the heuristic is that every time a program is moving from, so we have these 3 domains. That's like user code, which is code you're writing that's not a Node module. And then we have Node Core code, and we have NPM modules. And every time you do an async operation, so in classic callbacks, every time there's an indentation, that's moving your code between one of those domains. So here, it's a timeout. We're moving from userland code to Node Core because the timeout is in Node Core. So if this was a database, that would happen the same. So every time you're moving between those boundaries, it kind of takes everything in that call stack and groups it in a bubble. So for example, if you were doing 2 set timeouts in parallel, that would go in the same bubble. So interesting thing about that kind of heuristic is that if you have let's say you're calling out to a database, and your database, you're missing an index on your database, you'll have a lot of latency on your database. That'll actually show up in the diagram where you'll get a bubble, and that bubble will have a line down to a database, and that line will be very long because there's a lot of latency. And we actually also had another real use case there where we could see that adding an index to a database just shrunk the diagram. So that was helped us profile issues where we actually didn't change any Node code. There was just infrastructure, but async hooks gave us that information still, which is really interesting.
Very cool.
So that's basically it. It's pretty early, and we're still working on it, but it's pretty good, and I think it's pretty novel, at least in terms of like interesting new ideas.
Yeah, I think it's much better being able to visualize program execution that way than like a graph where every node is a specific call site, right, or a specific invocation. And because that just gets too big, and this is like a nice way to condense it into something that's readable, right? It might be interesting to have, like, instead of timing values, like call counts and stuff on there. Like you could have a few outliers that skew those significantly.
Yeah, so that's something we're actually where it's not we just haven't added it yet. We had the data because it's something that was interesting to see is that if you're measuring latency and you reduce latency, your throughput normally goes up, but your profile is the same length, so your graph turns out the same. So it's actually super important. So it's something that's we're gonna visualize really soon. It's because that's the only way to kind of see how your latency improves.
Cool. So how do we get access to this?
We just need some npm usernames, and I'll add you to the private package. It's just private because we're like cleaning up the docs and stuff like that, and like finishing up the tool. So then you can install it from the near form npm link. I'll put that in the notes. So
we can just private message you to, if people want to get set up with access, they can send it.
Yeah, private message me or Matteo. I'm Martin Tushing on Twitter, GitHub, or Matteo. I'm sure you have Matteo's information, and then we'll get people set up if you're interested in trying it out and giving feedback. Again, it's still pretty early, but this is why we want some feedback now, especially from people who know about the underlying data.
Yeah, also because some of those analyses might be totally wrong. So that if it's very hard to know if it's doing the right thing or not, to some extent. Like we spent a lot of time looking at this diagram, is it actually doing this thing correctly? Matthias, can you show the promise one, the promise series one, because you didn't show that, because that's one of those few things that we spent so much time on this. So yes, anyway, if you want to send us. We can start an email thread if you want access. We can just give you access. This is going to be public sooner rather than later. Like it's not something that is going probably in May or something like that. We're going to launch. We're actually starting to writing and launch things. It's not really a secret that we have been working on this. It's more about producing something that's useful for people rather than doing a big splash with something that doesn't really work. So,
right. Yeah.
More, and then keep iterating on it in the open. So this is actually pretty interesting because it's pretty interesting.
So this example is pretty funny because this is one where we don't know if it's a bug in async hooks or in profiling in general, or if it's just us visualizing it wrong. Basically, this example here on my screen, where I'm doing the same example as before, but I'm awaiting the promises in series. So kind of like the series of where I was reading file and callbacks, but just as promises. And the profile for this turns out really interesting because it kind of looks like this, where you have a bunch of fork promises, not depending on each other, then most of them going back to a big promise. So this looks like a parallel execution. But it's very much a serious execution. And me and Matteo was talking about if this is probably related to the fact that the async await probably end up as a promise chain from the same promise, and that might look like that in the profiling data. But it's kind of
with what version of the Node did you test this?
Oh, I'm running on latest 9, I think. Yeah.
I see, because there was this bug that recently surfaced where async hooks were not properly fired in V8, but that's only in Node 10, I think.
Right.
Yeah.
So I don't think I've ran this one in Node 10, but I've seen this kind of similar everywhere. And again, this is like, it also might be us doing something wrong in the analysis pipeline. It also might be us just not understanding completely how async await unwraps in a profiling aspect. But it's definitely interesting and very counterintuitive about what I would expect it to look like. Yeah.
It's interesting that one of them appeared to be like directly descended from the outer like HTTP connection, and then like the other two were from like Common Bubble. Like the first series awaits was like attributed properly, and then the other ones weren't. Or like,
yeah. So again, like the heuristic is that this is where code moves from one code to another one. So my guess is that this big promise here, like I need to dig into this more because it's kind of like a new discovery that we found. But my guess is that the big promise here is like the wrap promise that wraps all the async awaits, and that's the immediate child of the HTTP once you unwrap it. Once you unwrap the async awaits, and then that's why everything kind of happens below it. But then we also have this throwaway promise over here, which is kind of weird. That's the first promise in the series. So yeah, again, it's interesting at least. It looks pretty though, so that's cool.
It seems to me like the attribution of the FS promise to the HTTP connection is like it's making that attribution before the await happens, not after. So it gets attributed to the synchronous context that like until it gets to the first await, I guess.
It could be like that, yeah. Yeah. So yeah, that's basically it. Thanks so much for listening.
Thanks, Matthias. All right, we're 13 minutes over. Anybody have anything else?
Yeah, anyways, I would be very welcoming any comments on the document that I wrote about promise hooks.
Yeah, I added a few.
Can we share this with Andreas and Trevor and ask them why an async number and why the API is designed that way?
Yes,
because
definitely. So if you can reach out to Andreas and
mostly that for historical reasons.
I will see if I can get hold on Andreas and ideally Trevor via node source, whatever, Rod or somebody, just to explain if they can write us something about that part of the API, why it was designed that way, if there was a rationale or something, because that's something that we might want to do differently or something like that.
Yeah, that would definitely help.
The whole use of numbers kind of derived from like super olden days of the like async listener was kind of meant to originally was supposed to be like CLS in Node, but nobody wanted like all of CLS in Node, and they decided that like there was too much overhead to building this nested object thing, so they decided to like try to identify each context with the number instead, and then that number idea just kind of stuck for some reason.
Yeah, well, I'll put out an action. I put down an action item on me. I'll try to circulate this to them and see if they can explain a little bit. If they can explain the rationale about having an ID, because this is something that it's if it's there, it was designed that way for a true reason, or if it's an accident and
super useful, right? So I think I'm definitely +1 on ID. So I don't think that's really the question. The question whether or not the ID makes sense, I think it does. That allows you to do offline processing post-mortem.
Yeah, absolutely. On that, yeah, I agree. I'm just saying only not having the reference on all the other events.
Yes, that's a key question, and my guess there is because the way it was imagined was that you'd keep a map and you'd use the ID as the index, and you'll just store the data there. So that's why you don't need the resource. That's my guess.
Yeah, that's pretty much exactly it. Was just mapping from the ID to whatever thing you want it to be. So in the case of APM, like you oftentimes don't actually want like the resource itself. You want your own object that describes what the resource is doing or for or whatever.
Yeah, but if we can get over through that, it seems feasible. If we get the reference, we can attach the resource. We can attach a symbol to that reference, to that resource, and that gets exactly the same thing done.
My guess is back in async listener days, symbols did not exist, and
so that's
private properties would have been terrible.
Yeah, that's probably the deal. So
lack of symbols and lack of like wanting to mutate existing objects.
Exactly. Well, if with a private symbol, it's not a big deal. So we can mutate that using a private symbol. So that's fine. So yeah, I think we should just add the thing. That's actually very simple. And maybe not having the performance penalty on if there is no destroy hook setup or something like that, might be pretty nice. But we need to talk about it later on, and we'll provide some feedbacks on the proposal. I have to go, folks. I don't know if there is some more questions about BubbleProf, but if there are, like, reach out to Matthias and me, and we can definitely hook you in and discuss it together.
Great.
Okay.
Thanks.
Yeah,
Perfect.
thanks.
Thanks, everybody.
Bye-bye.
Bye.
Bye.
See ya.